All right, so there are different types of patterns question, and one of them is when it has the common difference. So in this case, we have common difference because from 5 to 9 is 4, you add 4 each time, so it's a common difference. Same thing every time you add in. So what you're going to do is you're going to put 4 before the n, and then you know it's plus or minus a constant, right? So the 4 is the common difference. If it was 3, you'd put 3 before it. Any common difference you get, you put it before the nth term, the n, sorry. And then you work out either 1, 2, or 3 that you have to see what you do to get these values. So let us say I choose 3, right? So say 4 times 3, right, which is 12, plus or minus what will give you the 13 as the value. So obviously it's plus a 1, right? That'll give you 13, right? That means then the formula that go in there is 4n plus 1. But you don't just do it, you cross check. So you cross check with another value. I have used the 3 already, so I'm going to use the 2. 4 times 2 is 8 plus 1 is 9, so it's working for the 2. Or if you had used the 1, you would get 4 times 1 plus 1 is 5, right? So it works, and then from there you can get any other value. For the 5, you could have just add another 4, or you could use there to get it. 4 times 5 is 20 plus 1 is 21, or if you had just add 4, you would get the answer. So that is a common difference 1. Similarly, for the area of the the number of dots, right? No, we just don't have number of dots. The area of the shaded region. I skip this one because you will see square numbers, because you don't have a 1 there, but the 1 is understood. So it's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So that one would just be n squared times the pi. So that one is not the same pattern. That one is just square numbers before the pi, which you can see because the students have to learn their square numbers up to 20 squared. So once they know that, it will be easy to identify it instead of saying some children just add it like saying you're adding odd numbers or whatever, so they'll add 3, then 5, then 7, then 9. Nah, they have to recognize that it's a square numbers pattern and put it there. The only difference now, it have a pi by it. So that is not the same pattern as those there with the common difference. Then we go into this one, which you will see is a common difference, because if you understand that is a 1 that before that pi, right? So you go 1, 3, 5, 7. Some children will say odd numbers, or you could think it's plus 2 each time, right? So plus 2 with the pi, right? So you know it will be 2 before the n, right, for the nth term. And then to get what that go in there, plus or minus a k, which is a constant, you work it out. Forget about the pi for now, right? So you go you either use 1, 2, or 3. So let me see, I'm going to use 1 this time, right? So 2 times 1 is 2, obviously, but it have to give you 1 there, right? For the 1, it have to give you 1 there as the coefficient there. So 2 plus what to give me 1, plus or minus what? Then it's obviously a minus 1, right? 2 minus 1 will give me 1 there. That means the answer is 2n minus 1, right? And just put the pi outside. Now, again, once you get what it is, the common difference, you put it before the n. Then you use one of the 3 values they normally give you to get what is the plus or minus k. This time is a minus 1, that is the constant there, right? So if the person had used 2 instead, they would still get the answer. So 2 times 2 is 4, and then how do you get 3 from 4? You minus 1, so you still get the minus 1 there. If they had used 3, it will be 2 times 3 is 6, and then 6, how do you get 5? Would be minus 1. So in each any case they do, they will get 2n minus 1. So when you get the 2n minus 1 from just using a value, right, you cross-check with another of the 1, 2, or 3 values, right, so that you will get the same coefficient there, the same number there, right. So the answer there is 2n minus 1 times pi, because pi j is just an outside of the brackets, we put it, right. Okay, so last one under that same question is this one. Oh, this one different. So let us go, because that one is not a common difference. That is 4, then 6, then 8. So we'll go back to that just now. We can check the same types of questions first. We go to July 2021. The one we were doing was January. Now we're going to July 2021. And you see the similar concept where you have a common difference, right? Because 5 plus 6 is 11. So each time you plus in 5. So what is the nth term there? 5n, and then you know it's plus or minus something that go in there. To get the plus or minus something, you use any of the 3 values there, 1, 2, or 3. So let me see. I'm going to use 2 this time. 5n plus or minus k, right? So I'm going to use 2 this time. 5 times 2, 5 times that 2 is 10, and then 10 and what will give me 11, plus or minus a constant, then obviously going to be plus 1 to give me 11, right? So when you get that, you try it with another value, right, to see. 5, let's try the 3. 5 times 3 is 15, plus 1 is 16, that means it's working. So once you get it, you try another value out of the 1, 2, or 3 to see if it's working properly, if you didn't make error, but this technique is only used for common difference. Similarly there, you plus in 3 each time, not true? So the plus in 3 each time is a common difference, so you know by the n is a 3n. Now the plus or minus what a constant, right, is how do you get it? You use the values there, 1, 2, or 3. So let me see which one I'm using. I'll use the 2 again. So you get 3 2s, 6, and you want 8 from it, right? So obviously it's plus a 2 to give you 8, right? So it's plus 2. Once you get the value, you can cross check, or you could use another value and see. Let's watch the 1. 3 times 1 is 3, plus 2 is 5. That means that is the answer. But if you were trying it initially, you would say 3 times 1 is 3, and then you'd be asking yourself, that 3 plus what would give me the 5, and then to give me the plus or minus the constant. In that case, it's a plus or 2. Sometimes it's a minus or 2. For example, if you had a 1 there, then it would be minus or 2 to give you the 1 from the 3, right? So basically, that is it. So that is one of the common patterns that come in CXC. Is just the difference, the common difference. You know, I think in a higher maths they call it something like arithmetic progression or something like that. So that is the simple way I do it. Just put the common difference before the nth term and then say plus or minus what to give you the finishing up. But to get the plus or minus what, you use one of the 3 initial values. Normally it's 3 values they give you because the pattern doesn't start with 2. It's with at least 3 values, right? So you can use any one of those things there to get it. From time you still get the nth term, which is what, when I correct CXC, is what the students leave out, the nth term. But from time you get that, you can actually work out any other thing from there, right? Instead of, you know, staying on your calculator and adding to get 66 and counting how much times you used to get 66, then that 66 would be easy to get. Because you would say 5 times something plus 1 equals 66. That means 5 times the something equals 65, and then when you divide by the 5, you'll get your answer. So you get, what is that, 13? Yes. So you know it's 13 that go in there just from that. So instead of they adding and counting, they could actually work it out backwards from the nth term back to the other things. Or yes, so similarly there, 5 times 5 is 25 plus 1 is 26. So they know it's 26 that go in there. However, another child that is adding, they will still get the answer. And I see when I'm marking it, I have some children that have long lines until they get their 66 or their whatever answer. But you can always go, once you have the nth term, you can get the other values there.